Hello everyone, my name is Ziye Chen from the University of Melbourne. Today, I wanted to give you a presentation about our work in ICCV 2023, that is, generating dynamic kernels via transformers for NAND detection. This presentation includes 4 parts, which are background, method, experiments, and conclusion. And first, I wanted to introduce some background about our work. NAND detection is a fundamental task in autonomous driving system. It is a supervised learning problem, where during training we use pairs of image and labeled NAND points to train the detection model, and during test, given an input image, the model will predict the corresponding NAND points. NAND detection is a challenging problem, where the NAND lines usually have complex topologies, such as curved, forked, and dense NAND lines, and they are often blocked by vehicles and pedestrians. Existing methods usually rely on strong human priors to detect NAND lines. For example, the anchor-based methods detect NAND lines by generating a set of predefined anchors and then regressing the offsets from the anchors to the target NAND lines. And the parameter-based methods represent NAND lines with parametric curves and then detect NAND lines by predicting the curve parameters. However, the NAND lines in real scenes are often curved or forked, and the human priors can hardly handle these complex topologies very well. Recently, dynamic convolution-based methods have shown promising performance by considering the features from some key locations of a NAND line, such as the starting point as convolution kernels, and convoluting them with the Hoare feature map to detect NAND lines. By reducing the reliance on specific prior knowledge, these methods can achieve better results than the previous anchor-based and parameter-based methods. However, the kernels computed from the key locations fail to capture the NAND line's global information due to its long and thin structure, leading to inaccurate detection of NAND lines with complex topologies. In addition, the kernels resulting from the key locations are sensitive to occlusions and NAND intersections. To overcome this limitation, we propose a transformer-based dynamic kernel generation architecture for NAND detection, which further reduces the reliance on specific prior knowledge. It utilizes a transformer to generate dynamic convolution kernels for each NAND line in the input image, and then detects these NAND lines by convoluting these kernels with the Hoare feature map. Compared to the kernels generated from some key locations of a NAND line, the kernels generated with the transformer can capture the NAND line's global information from the Hoare feature map, enabling the effective handling of occlusions and NAND lines with complex topologies. Our framework starts with a CNN backbone to extract a feature map from the input image. Then, a transformer is applied to generate convolution kernels for each NAND line from the feature map. Specifically, we use learnable NAND queries to learn different NAND prototypes from training data. Then, we calculate attention maps to find the most related pixel features for each NAND query. Then, we aggregate the pixel features according to attention maps to obtain the NAND features. Then, we project each NAND feature into convolution kernels with MLPs. Finally, the NAND points are obtained after a dynamic convolution followed by a post-processing. We evaluate our method on OpenNAND, KernelsNAND, and CoolNAND datasets. And the results show that we achieve SOTA performance on all the 3 datasets. The visualizer comparison results and attention maps also validate the effectiveness of our method. And here is the summary. And here are the references.